Hey, hello, welcome to the show. It's me, JP. It's time for another episode of John Park's Workshop. You are right here with me in the workshop. Thank you so much for stopping by today. We have people over in our chat that I'd love to say hi to. Thanks for stopping by in our YouTube chat. Blade Wire, Dave Odessa, Johnny Bergdahl. Welcome, one and all. And then, of course, everyone over in our Discord chat. If you're not... Oh, that's not the Discord chat. Let me fix that right now. If you're not aware of it, we've got a Discord chat over at adafruit.it/discord. And if you jump in there, you can head over to the live broadcast chat channel and hang out during a show, or check one of the many other channels anytime during the day. I think we have something like 30,000 members of our Discord, which is tremendous. And okay, I'm gonna have to actually re-add this. Hold on, this thing decided to go kaput. If you're wondering where the chat is and you were somewhere else, like, let's say, Twitch or Facebook, and it doesn't seem like anyone's around, that is because I don't look at all those chats. I try to keep it mostly in one place, so the Discord is a good bet. All right, here we go. And where's the Discord drop down? There you are. Boop, 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 boop. There it is. Hey, let me slide that over to the side. That's the Discord right there. Go check that out. Let me finish zooping it up there. Oh, yeah, so you can see our channels there listed on the left. I have not practiced my Swedish since the last time. I haven't been back to IKEA. I don't know where else to practice Swedish in Los Angeles. Probably there's somewhere. All right, so that was a long way to say check out our Discord, but at least now I've got it up on the screen there. So hello to Thin Man, C. Grover, Johnny Bergdahl, Andy Calloway, Jen Hendrickson, and more. Some Nice. Hello, welcome. Let me grab a sip of water here. Try to stay hydrated. Can see nothing. Oh, that's because I never hit this button. Thank you. I added it to my preview monitor and never shot it over to the actual output. Thank you for the heads up. Thank you. Charles Berniford also caught that. Appreciate that. Give that a second and that'll show up. Anytime I add windows and things mid-broadcast, I need to remember to manually shoot them over to the output. But there it is now. Okay, so what have we got going on today? We have a packed show. Bunch of cool stuff I want to do, including I have a coupon code for you to get some savings at the Adafruit store. I've got a product pick of the week recap. I've got a CircuitPython parsec for you in the continuing series of the Circuit Playground library stuff. I have a little tool tip that I want to give, tool recommendation. And then I've got continuing work on our ambient machine project, including I'd like to show you how I'm going to create some of the looping ambient sounds that will be played on it. So those will be samples. We'll talk a little bit about sample stuff. I may actually do a combination of samples and synthesized sounds using Synth.io. And I'll also talk about some issues that I was running into. I'll give you some examples of the issues I was running into and why I'm now considering smaller samples plus synth stuff. Todd, no, not ambient machine. No. We need to get hype. Come on. All right. The discount for you, the coupon code today is that right there, Looper. If you want to get 10% off in the store, head right here to the store. There's an example product, but if you go to products and then over new products, view all, you can find some cool new stuff here, or go to products categories, click shop categories, view all, and look for some stuff. Is this record still available? Look at that, $2.99. I don't know if discounts apply to that on sale stuff. Do they? They may. You can't lose. If I keep clicking on this, someone's going to buy it. I wonder how many we have left in stock. Cool vinyl pressing there of the Bartle Beats album Frequency. I love those songs. But anyway, go pick some stuff, throw it in your cart, and then on the way out, there'll be a little coupon code field. Type that in right there, Looper, and that will get you 10% off. It's good until midnight East Coast United States time today, and then it will turn into a pumpkin and go away. But that coupon code is good for the day, so no hurry, no rush. But if you think of some stuff, or if you see me talking about some things here on the show today and you go, oh yeah, that actually reminds me, I want some parts to build an ambient machine, then maybe go do that and get yourself 10% off today. All right, so next up, I've got this show that happens on Tuesdays. It's the Product Pick of the Week show. On it, I pick a new thing and show you how it works and give you a big, huge discount. That was the new one this week, a hot one, a really cool one. We sold a bunch of these, and I'm excited to see the kinds of projects people do. And when I do one of these, I also like to make a little 1-minute version that you can enjoy later. So here it is. It is the Prop Maker Feather RP2040. This is an all-in-one solution. So this is the microcontroller right there. You can see it's the RP2040. And this then has the onboard accelerometer. It has a NeoPixel driver. It has the I2S amplifier. We have an input for a button. And one of the things you'll notice is that we now have built onto here a really nice, neat set of screw terminals. No soldering required. This has the Prop Maker Feather wired to it. I have a servo, speaker, and I have a NeoPixel strand, and all of that is just screwed right in. And sweeping of this servo here, rainbow NeoPixels running here, and then I have a button, some plug-in wiring that will allow me to adjust color of the NeoPixels. It is the Prop Maker Feather RP2040. Yes, it was. A cool one right there. So let's see. What else? You know what? Without any further ado, let's jump into this week's, how do you say, CircuitPython parsec. Okay. Are we looking good? I think we have it. Let's do this. For the Circuit Python parsec today, I wanted to show you how you can use the light sensor inside of the Circuit Playground library. Circuit Playground library makes it really easy to use your Circuit Playground Bluefruit or your Circuit Playground Express with really high-level commands. In this case, I want to use the little onboard light sensor. And what you can see here is if I take a flashlight and shine this at my... Uh-oh. Did it break? Let me let's see. Let's see what's broken. If it's the connection. There we go. That looks like it's working. Okay. So what was I saying? Oh, let me bring up, I got two code windows here. All right. So what I'm going to do is take my little flashlight here and shine it at the little light sensor that's built onto the Circuit Playground. And you can see as I increase and decrease the amount of light hitting that, we can plot that value right here in the Moo plotter. If I open up the serial output, you can see we have these units. They're not any particular unit. They're not lux or nits or anything like that. But they are, I think, 0 to 320 is the range of the type of light sensing that we output using this library in CircuitPython. It's an analog read internally. I think it varies in Arduino versus CircuitPython with the ranges that you'll see. But you can see here, I'm just simply measuring that and outputting a value and then plotting it to the graph. Now, if you take a look at my code, the way this works, the simple demo works, really all I've got to do is import from Adafruit Circuit Playground. I'm importing CP, that's the Circuit Playground library, and that means I have access to everything on board, including cp.light. That's all you need to do. If you ask for the value of cp.light, it returns that value. Now, if I want to do something a little bit snazzier here, what I'm going to do is take that value and turn it into a sort of light meter using neopixels. So you can see here, we've got one neopixel lit up. If I take my flashlight and shine it at the Circuit Playground Bluefruit, we're getting a little meter there. I'm going to turn this to a less bright setting on my flashlight. That helps for you to see those. You can see that those neopixels are lighting up based on the read. And in this case, it's the same thing. I'm just simply getting that cp.light value, but I'm turning it into a remapped value that can tell the neopixels 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 whether or not they're going to light up. And then depending on that peak value, we go ahead and set those, in this case, to a red at 4000, and then when they're not at that value, we set them back down to 0 so that they kind of erase as we go backwards. And so that is how you can use the Circuit Playground library that is how you can use the Circuit Playground library inside of CircuitPython to read the onboard light sensor. And that is your CircuitPython parsec. All right, I am always amazed about getting through saying Circuit Playground and CircuitPython so many times in a row without my mind breaking. It's not easy. All right, so let's see. Next up, let's do a little bit of a tool tip, and in this case, it's a gear recommendation. The other day, I was talking to our good friend Steve, Denki Otto, OK You're On. He goes by many names. You'll see him in the chat sometimes. Steve is, among other things, a synthesizer builder. He creates various cool sound computers and synthesizers and MIDI things. And he was wondering about the threading on his device, which I put away. I don't have it right here right now. But there are some parts. They're actually the 1/4-inch jacks. So for this type of 1/4-inch plug, there are 4 of them on the back of Steve's Shield XL product, and he was wondering about what the thread pitch is. And so he said, do you have a gizmo for that? Because you can get out some calipers and measure the distance between a couple of threads, particularly for the threads per inch. But there's also another way of looking at thread that's thread pitch, which is sort of a relationship to the type of screw or bolt that you're measuring. So I've got a gizmo. Let me go over to the bench cam here. And I don't need to use this very often, but when I do, it is definitely the right tool for the job. So let's let me switch that upper camera there. Sorry about that. To that one there. There we go. So this thing is called a 28 blade 456 and 0.5 to 6 millimeter screw pitch gauge. And that's what it looks like right there. It is a multi-tool type of gauge, similar to a feeler gauge, if you've got one of those, if you run across those. And this has both a metric and an imperial units to it there. Steve's turned out to be 20 pitch, so sorry, I don't have it here for a demo. I can grab some other screw. It was, where'd it go? That one right there. And so you can see what you do is just simply press that up against a threading that you're trying to determine, and you can see which one fits best. That's probably your threading. So here's an example on this screw. If I try that, I don't know how close I can get. Sorry, that's about as close as I can get there. I don't know if I can get the closest I can focus. Whoop. Right about there. So basically you're looking for space. So this is not 20, not 28. Might be 32, and then what I'll do, depending on the screw, is go and check both the imperial and the metric side. So that's it. Now you can also find sometimes in hardware stores, especially for larger bolts and fittings for plumbing and gas and air fittings, they'll have a little board that you can screw your bolt or screw or fitting into if you're unsure, and you just kind of find the one that it fits into right. There are also hole gauges for diameter, but these are really nice because they're really specific to different pitches of thread that you have. And I got this one at a specialty store. You can probably get them online. I got it at essentially a bolt and screw and bolt and related tools type of store. Made in USA by I have no idea whom. There's no name on the little package anymore here, if there ever was one, but that number might show up with something if that's a part number there. So that is my my tooltip, is this screw pitch gauge. Right. So let's see. What's going on? Are we all good? Yeah. Okay, so moving along then, I wanted to get into the Ambient machine project. So you can see it over there, hanging out. That's the Ambient machine. So last week I talked about using these little IKEA drawers, these Baltic birch drawers that come in a thing called moppe, which is a drawer set that has 3 small, 2 medium, and 1 large in a nice case. Looks like this here. And by the way, I noticed this morning I was watching one of the Arduino Uno Rev 4 announcements, and there's a moment where Massimo Banzi is sitting in front of a stack of about 10 of those. So someone in the Arduino office has built themselves a sort of chest out of a bunch of those. I'm not sure, maybe they drilled them together or bolted them or something. So what I've done since, and I can't remember, sorry, I can't remember if last week, I might have already done that drilling out there. I used the laser cutter to make it nice and fast. You could use a drill and a drill template, which I'll Johnny Birdell says, I hear you've been practicing. I don't know. So this will be something that you can make with or without a fancy CNC controlled laser. You can drill out some holes, 20 holes, pretty evenly if you use a starter, tape a template to it, and use make a little starter hole before you drill. And then this one would be much more painful to do by hand, but I made a little grill for the speaker, and so I'm placing a smaller box inside the bigger box to essentially house the electronics and the speaker. So you can see behind there I've got a speaker screwed on there, and I'll show it in more detail under that camera over there. I've put 10 of the switches on. This will take 20 switches, and I'm using an I/O expander to read those over I²C. And right now, what's in there? Let's take a look, and then I'll talk about some of my issues I've bumped into and some potential ideas. So let's get back over here. By the way, one of the things that I did with this for both the holes on the front and the speaker grill is I do a test cut in cardstock. I like to do this so that I'm not wasting real material. It's very fast. It's a couple minutes to make that cut here, and it's probably 4 or 5 times that once you're moving the laser slower to cut through some chipboard or mat board like that. So that I can then do a reality check. I've got another one of these here. A reality check on before I commit to the material there. So I set this upper left corner distance as the upper left corner of the cut, so everything there should line up. Another thing I found very useful with this is having the multiple drawers gives you a kind of nice work surface when you start screwing in those switches. So let's see. You can't really set that down on its face once you screw those through, but I made the pattern small enough to fit inside of the small size one since I knew I'd have that back box for the sound resonator. So if I flip one of these like this, you can actually set it on that as a little stand, which is nice. So what I've got inside of here is not put together, it's just kind of shoved together. But you can see here I've got my speaker, and I made the pattern here fit the mounting holes of the speaker, the little ears on the speaker there. And I'm just using some M3, I think they are, or M2.5, I can't remember. This might be M2.5 screws with nuts on the back of them. And then I've got a long set of wires running from the speaker to my electronics here, which is set like that. Should make it a little easier to see. So this is a screw terminal block on the amplifier. That's an I2S amplifier, mono output. I have not adjusted the gain on this. I think I'll probably end up gaining that up, and that's a bridging of some of the pins on there that adjusts the gain on this one. I have a group of temporary wires here for a lot of things, so I'm in that sort of basically breadboarding stage. So I'm using the Metro M7, which has these female header pins in it, so I can use these jumper wires. So I put header pins on my amplifier, header pins on my SD card here. You can see I'm using a little right angle USB-C adapter just so the cable isn't poking too far out. Running the USB wire through this notch that's built into the moped handle, drawer pull. And then I've got this I/O expander. This is the MCP 23017. This has, what is it, 16 or 14? Is it 14? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 16 pins. So almost enough on its own for this. I didn't want to do a diode matrix. I wanted to make this as plug and play as possible with as little soldering. And so I'm going to use 2 of these. So it's I2C. I'll just daisy chain a second one. And so I'll have my first 2 rows of 5 on one and a second 2 rows of 5 on another. That'll make the code nice and simple. I could use 16 of them on this and then 4 of them on available GPIO, and you could do that too if you didn't want to spend the money on a second one of these. These, I can't remember, I think these are maybe in the $6 or $7 range. It's a banana, Michael. What could it cost? $10? And so you could do that, but your code will then have to deal with the fact that some of your I/O is coming from reading this little I2C expander and some is direct. No problem, you can do that in code, but I'm, for learn guide purposes, going to try to keep it simple. It means you could also expand it up to 32 if you wanted to do a similar project with 32. You'd have all the I/O built right onto there. And then you can see here I've got some arcade cabling, arcade button cabling that we sell, which I've cut the JST connectors off the ends. They're all using a daisy chained ground. So each one of these pairs, and you get a 10-pack of them, so that's 20 of these, which is exactly the number you need if you get 1 pack of these. Each of these are just terminal spades plugged into and not soldered to these switches. Again, it just made assembly easier, so I can pluck those all off, and then I ran a single ground chain to them and have just 1 ground wire running. So that's what it's looking like inside. Let me double check the chat to see if we've got any questions. Mouse said that they have a drawer full of batteries. It's part way to an Ambient machine for sure. You can also see here I've got this connected to one of our little metal grids, swirly grids, using nylon M2.5 standoffs. That makes it easy to get this contained. Otherwise, there's a bunch of parts just rattling around in there. So I may add a couple of holes to the bottom here so that that fits in, or some other attachment method to this, again, just using these direct. And so one of the things that I've got going on here is this SD card reader. So this is the SD card breakout that works over SPI. Flip this around so you can see that. This is the bottom side, and that just has to do with the direction I happened to have put my header pins on there. So this is the micro SD breakout used with SPI or SDIO. So we can't use SDIO on the Metro M7. My plan was to put my WAV files for sample playback on the SD card and then be able to play them with combinations of these switches, different samples. However, since we're not using SDIO, the speed that we can stream the WAV files off of here seems a bit too slow for our needs. If I get more than about 3 of those playing at the same time, it really starts to chug and stutter and sound weird. So I'll demonstrate that for you. I'll also show you one possible solution I'm looking at, which is forget the SD card. I can make small enough samples because they loop to just put onto the flash memory on the M7. Potentially do some synth I/O and some samples so that I can have bigger samples on the available space. And then there was also a suggestion, I think Tyeth in the chat was talking about this earlier, and Lamore mentioned it to me yesterday, and Dan Halbert did, about upping the SPI bus speed for this purpose to its max. So whatever its default is not, I think it's what, 30 kilohertz, 30 megahertz? One of those probably doesn't make any sense at all. 30 something is, I guess, the maximum speed we should be able to do, which is faster than the default. So I want to try that, and maybe in the chat, Tyeth or anyone else who has experience with that can see if I'm doing it right, if we can get any improvement there. So what I'm going to do, though, is I'm going to bundle this up, and all I really want to do is get that USB cable there out the side. By the way, one of the things I may do is add a USB panel mount USB port right here so that we can power it from USB, and maybe a power switch on the back. But for now, I've just got an internal cable in there that will be able to plug into power and data when we're using it. So let's, 30 miles per hour, that's it, mouse. Megapixels? I don't know what it is. Something. Okay, so what I want to do is move some stuff out of the way here. And let's plug this in, see if it's working. Okay, it makes sound, that's good. So let me get a camera figured out here. My camera arm broke. Nothing a clamp can't sort of fix. And let's look at this view of the world. Focus that. Okay, that should be good and bright. And then let me get just a, I don't need that plotter anymore. Get rid of that. And I will remember to push these changes over to the live view, like so. And let's open up. Oh God, please tell me it didn't just save, auto-save. Oh, I have multiple. Okay. Crossing fingers. Phew, okay. So that's the code that's running on here. And I'm going to take this cabinet mic and set it here, so hopefully you can hear that. So tell me how this sound mix is. So you should be hearing me still talking, as well as 0, 0, 0, 0. This goes with Ionescu's GIF pretty well, actually. All right. So I'll turn that off for a moment and wait for streaming to catch up with the chat, so you can tell me how that sounds, how that works. 0, 0, 0. Okay, good. So I'll leave it at that. So right now, what I have is that is playing off of internal flash. So what I'm going to do is I'm going to put this back to SD card. And let me open up a Terminus. Okay, so you can see here, first thing code does is it checks that directory and lists the contents, which are WAV files named bot num 01 through 10. And I think what I'll do is set the, okay, so let's tell it to open up just one WAV file. Okay, sounds pretty good. Now I'm going to say, okay, open up 2. So it's going to open up the one that says 0 and the one that says 1. These, by the way, made my life a lot easier with this and I think a previous project where I wanted to know which switches I was doing and not try to remember, oh, this bird call was the first switch and this car horn was the second, and so on. So I generated these little machine vocoder machine or sample voices, synthesized voices. So you'll notice right now, if I flip switch 3, 4, and so on, I can tell the switch is gone, but I'm not loading up enough voices to play those. So let's go to 4 voices. So you can hear it is having trouble. It is stuttering and it is slower. Now you'll notice there's no difference between the just playing one by itself or playing 2, 3 of them together in the sense that they're all playing all the time. I'm just using the mixer, the CircuitPython audio mixer to turn up the gain or down. So I can turn on 3 of these. Okay, so let's be bold. I've got 10 switches here. I've got 10 samples. That's everyone, right? Okay, so that's not going to cut it. So one of the suggestions, and let me answer a question. Penpengo asked, what kind of sample rate are those waves? So these are mono 16 kilohertz samples. I'm going to open one up in a second to take a look at everything we can about the file. They are probably around where we want them, and so the issue is if I take these and run them off of flash memory instead of SD, it's kind of doing what I want. So now there's 10 loaded. Did I hit save? Let me hit save. Oh, I didn't change what I thought I changed. Sorry. Here we go. So this is where I'm telling it to grab off of local flash storage instead of SD. So you can hear it's playing it back what sounds like just fine to me, and there's 10 of them loaded. I love it. Obviously, during testing purposes, this is not a soothing ambient machine. It is a nightmare box, but that's okay. So that's possible. And so one of the questions is if I'm playing it off of an SD card. Let's see. We'll leave it at 10. Off of SD card. This was the default SPI bus speed. And my question is, am I properly adjusting the speed of the SPI bus in this configuration here? So this was based on just looking at some of our, I think there's a guide from Limor on SPI bus. And so this, by the way, to go up to the top here, this is using SD card I/O. The SD I/O is the super fast one that runs on, I think, maybe just the RP2040, maybe some others as well, but will not run on the M7. And I don't think it's going to. So if I'm trying to use SD card with SD card I/O, is this the proper way to try to boost the speed? So here's what it sounds like with the straight up default. Let me let that save. And then this is the attempt to boost the speed. So let's see, 30 megahertz SPI SD card. Ha, says Pen Pengu. SD card config, SD config set CS pin 17, SD config SPI speed. So Tyeth, do you know, or anyone else know, in CircuitPython, if this looks correct for trying to adjust the speed? You can see if I reduce this speed by orders of magnitude. I thought I had gotten it to do stuff, so maybe this isn't working right now. That's sounding the same. I thought I had found ways to adjust that. Let's see. Oops. What about... let's see. So Seagrover said I can double check the bus frequency to print SPI.frequency. Let's do that. Hey, have my changes not been happening? Oh, why is that? Oh, let me close this. Why am I not seeing that frequency? Let me get rid of, actually, sleep. Let's just hold up a second here. It is not printing that. Why is that? Is it because I'm not creating SD card yet? That is why. Okay. Let's do it right here. Oops. Why does it not want to print that? I'm going to get rid of this other print. Hold on, I'm going to just clear the Disco Tool session there. Restart that. I'll also add some text to that print SPI frequency. That is mysterious. Why won't it? Anecdata says to verify the speed of a particular device on the SPI bus, the code needs to be in its context while it has the bus. Oh, I see. So that's not in the right context, apparently, huh? And then someone else said SD card IO.SD card takes an argument for the speed. Okay, well, I'm going to shut that mystery down there for a second. And I can do it here. So SD card, so SPI, CS, and then baud rate. All right, baud rate equals 30 underscore 000 underscore 000. Well, that makes it a lot easier to see. Let's try that. Yeah, that's a good question. Cedar Grove. Why was that in italics? That's really bizarre, right? Is that happening anywhere else? It is. Oh, that's just this editor's cute little trick there. Yeah, it freaked me out too. I don't usually use this one. Okay, so if I'm setting it down here, don't need that up there. Now let's try changing this. Can it go lower and remain the same? Yep. That definitely sounds weird. Okay, so if that's at 30,000, and I believe that is what Dan, or 30, yeah, I think that's what Dan said was the max. We can try to be optimistic and just bump it up. Nope. All right, so I think that's our max. So it seems to me, unless someone has any other ideas about this, using SD card I/O with that bus maxing out there, I think that's not going to work. So, like I said, it's okay because I can play these off of local flash, and these are actually, in this case, currently very small files. Pen Pengu said it worked over 60,000. All right, let's see. Let's go back up here. 120. Sounds like a good number. I don't think that's any different. I don't think so. Feels like that's where it's So I think Penpengu, this may be related to the board. I don't know if you're trying this on a Metro M7, but that may be our limit on that. But like I said, if I just play these off of Flash, as long as I can cram them into there. So I want to have 20 samples, let's say, or maybe 16, and say 4 buttons for some other interface things. This may do it. And so, oh yeah, and that's a good point. I am using a pretty miserable SD card, and I definitely need to try like with a good one. I wasn't using a good card in there, and that's such a basic thing. I should have thought of that sooner. Card speed can vary so much with trying to stream waves. So I will try that, but what I want to do either way is talk about making my sounds for this, making my looping sounds. So what I'll do is I'm going to put this off to the side. And thank you for your active participation in helping me determine if I was doing the speed thing properly, how to do that. 'Cause I didn't know. All right, so I'm gonna mic this little. Oh, Tyeth says need to adjust the bus I/O SPI frequency via configure inside the tri-lock. All right, I'll try that. I'm willing. Let's do it. Sorry, I know there's a little bit of a lag here between when you see stuff and when stuff happens in the chat and when I do them, so I might miss your suggestion. Okay. Okay, so let's see. If we go back to SD card, adjust the bus SPI frequency. Does this look right? So I'm creating a bus I/O SPI on board serial clock, ISO, MOSI, while not, so waits to lock it, then I configure that speed, and then unlock it. So that's one version of this. Let's save that again. So Tyeth, does that look right? Does that look like I am setting my baud rate properly inside of the locked bus I/O, or was it SPI frequency and not configure? SPI frequency. And what is that? Equal? Can I do this? No. So maybe that was it. Configure and baud rate. Is that right? So we'll set the bus to 60 and baud rate in the SD card. So both, hey? Sounds the same. Todd said SPI frequency of 31250000. Is that this? 31250000. 3125. Seems about the same to me. I'm not sure if it makes enough of a difference. Yeah, frequency is read-only attribute, so you can just ask for it. That is weird that it didn't want to print it, huh? Let's try it right here. Print SPI frequency. It really doesn't want to print that. That's the weirdest thing. Does it not print during lock? I don't know. Okay, I'll wait a moment here in case anyone has, before I pull this apart. See if anyone has any other thoughts. Yeah, it does sound about the same, right? Okay, so let's move on then. Let's assume I'm going to get the sounds I want onto flash memory. Can I print that? Print the SPI object? Nothing wants to print. only the wave list. Okay, I'll stop noodling with that now. Right there. That was it officially. I'm going to unplug this. Here we go. I'm sure someone will come up with the answer. Actually, I'll leave it plugged in. So let's talk about this, though. So one option we have is to just fit what we can on flash. Another kind of cool option would be boots up. It plays, it loads up my samples, maybe a mix of samples in SynthIO, as a set that's stored on SD card, moves that to flash memory, and then plays from that. And then we could maybe just configure 1 through 5, whichever of those is on during startup, it could go and grab that. That'd be kind of neat, kind of a cool bonus feature. So either way, what I need to do is create some nice sounding loops, not this robot saying 0. We're done with that guy. So I'm going to go ahead and unplug this now. We'll proceed as if I'm, whoops, there goes that camera. We'll proceed as if I'm ignoring the SD card issues. And what I'm going to do is I'm going to mic up this little external amplifier and do one of or a couple of these sounds and show you how this works. And actually, I may do the full process of getting these over to the device here. So what I wanted to show you here is, do that one, yeah. Here is VCV Rack, and you know I love this one because it's a Eurorack modular synthesizer that is free. You can buy some modules. These are all free modules that I'm using here. It's open source, and in this case, most of these modules are a virtual version of real existing modules that I like to use in real life. So the hardware modules from Mutable Instruments are represented here as free modules. So turn this up. And sorry, I just realized some of the last batch there where I was playing, the input of that mic was a little quiet. So it's a little spookier than I want to go in the end, but let's maybe noodle with this a little bit. I'm going to get this a little lower pitched. And let me turn back the feedback. Yeah, in fact, let's do this. Let's get rid of most of that spookiness. This isn't crazy soothing, but it's a start of something that's maybe just like a plucked string sound. I won't go too much into what I have happening here because that's its own thing, but I'll say short version of it is this first module on the left here. This is a module called Marbles in the real world. It's a random rhythm and pitch generator. even though it says random sampler. It's kind of a confusing name to be on there. And I have a wire, a little cable running from a pretty regular clock beat there. I'm going to actually make that a little less regular. So you can see sometimes it fires, sometimes it doesn't. There's a little chance that this T2 here, or rather T3 output will or won't play. And I can bias that so it's only skipping it every once in a while. And then on the right here, this one labeled X2, this is sending out different pitch information. I can run that into this next module here. So this next module is being triggered by that T, and its pitch is changing based on some random pitches selected within a scale and a small range. And then I can do other adjustments to that sound design. And while I'm doing that, I'll have that be a regular strike. A little more bell-like. Okay, I like that. Turn this volume down a little. And then I'm going into this one called Clouds, which does a little bit of granular and reverb types of things, depending on how much I blend between the original dry sound and the wet sound. We'll get a very different result. So I'm going to add a little reverb back in and feedback. Okay, I like that. And then the output of that I happen to be sending to a equalizer, EQ filter. So we're listening to just the low pass filtered version of it. So I'm cutting out a lot of high-end stuff just because I want it to be a little richer, lower end. If I adjust that for a second, oops. This has sort of all the frequencies represented. If I go through that filter, I'm just adjusting which frequencies are emphasized and which are kind of removed. So what I'll do now is record that. So if I come into this module down here and set where I'm going to record that to, ambient string, let's call this O2 dot wave, amb strings O2 wave. And now I'll hit the red record button and it's recording a wave file. I think I have it set to mono 16K 44 kilohertz. That's good. So now let's turn that all the way down. And then if we come over into Audition, and you could use Audacity for this or any other sort of sound editor, we can open up that WAV file. Before I do that, I'll say that here was a previous one, so cooking show style. I had done a previous one, and I took it in, picked a small snippet of it that loops fairly well. I don't have a perfect seamless loop happening yet. But then I pitched it down and elongated it so that it is not... Let me turn this one down. This is a louder gain here. So you can hear that one has a distinct sort of loop point. I'm going to remove those. I'll do that later. I won't do that right now here. But if we open up that new one we just did, let's take strings to wave. First of all, you can see I want to boost this gain to something like that, about -3 dB for its peak. We could also use a compressor or a normalizer, but let's listen. So this is what we... I like right there, so let's just trim that. Not bad. So it's a pretty short loop. Obviously, the longer the loop, the better. It's like 5 seconds long, 4 seconds long. The longer the loop, the better in an ambient machine. You don't want to hear a repetitive thing, but we'll see. Especially with mixing in some synth.io stuff, some noise, we may be able to use really short samples and get away with it, or I'll push those. So this right now, if you look at it, this is a 16-bit sample. It's mono, so it's just a single channel. It's not left and right channels. And the sample rate is very high. It's 48,000 hertz, 48 kilohertz. So what I want to do is export this, and I don't think you'll see this export window that shows up, but I'll just talk you through what I'm doing. I'm resaving this where I have my ambient machine samples, ambient strings 02 A, and I'm going to save that sample type as I think 22,050 hertz for the sample rate, mono, and it is going to be 16-bit. And I'll go ahead and save that, amb strings 02A wave. So now what I'll do is, let's go back here, we'll grab our machine. Now, previously I had been just ejecting my SD card and plugging that in. But now I'm going to just put this directly onto the CircuitPython drive. It's actually kind of nice workflow-wise. And let me see if I can convince this dying camera clamp. No. It snapped some little, here's a nice big clamp. Let's see if I can. There we go. At least see something. So what I'll do is, you won't see this just in the Finder. And I apologize, you won't see this. I'm going to take the file I just saved. By the way, before I do that, I'm just going to double check. In code, you can see when I am bringing in my wave files here in the mixer, I'm saying I have a sample rate of 22050, a channel count of 1, which means it's mono, and I'm 16 bits per sample. So that is the same. You have to be consistent with all your files will want to be these same specifications. So let's open ambient machine samples, and I'm going to copy that to samples. You know what, I'm just going to dump this in the same folder as my numbers. My list of wave files, that one that prints out there at the beginning, that is sorted alphabetically. So this one will actually show up first, since it's begins with an A, and my other ones begin with a B. So let's see what it thinks. I'm gonna samples numbers, Why did it not grab it? Am I sorting? Starts with, no, numbers, file name. Did I put it in the wrong place? Samples, numbers. Why are you not showing up? It is there. Am strings. It's named in a way that should be fine. Just to prevent confusion, I'm going to get rid of some of my SD stuff. That way it'll yell at me if I'm accidentally trying to do it off the SD card. Just for kicks, I'm going to open that one directly just to hear it play, since that's part of what I wanted to show here. So I can do what's the starts with? I thought it was not starts with dot and ends in wave, which this qualifies for that. Samples, numbers. I'm confused as to why it's not showing up. Let me just see if it's actually... I don't know why the name isn't showing up, but guess what? It's playing. Maybe, I don't know what's up with my printing. Printing went weird, huh? Let's quit Disco Tool there and relaunch it. No? That's really weird. Okay. So that sounds pretty good, actually. It's a nice sort of range of frequencies there for this box. So part of what I'll do as I design the sounds for it is find things that work well with this speaker, with the type of fidelity it has, with this enclosure here. And there are some tricks we can do. So when I have multiple sounds playing at once, we may be able to use some like LFO objects to massage the mixer volume. So I'll flip a switch and maybe that'll allow it to adjust its volume from 0.7 down to 0.4 or something. If there's multiples that can kind of fade in and out with each other, it would be kind of cool. Andy Calloway, getting a real haunted house vibe there. It'll be a challenge for me to make it less spooky, but I think I need to make it a little less spooky. And I should listen to existing examples of these types of more meditative sound boxes. Or not, or maybe mine's got a spooky vibe to it. I'll paint it black. So what I wanted to do actually is bring in this other sound here that I have, and it should, I don't know why it won't print, but it should just land on on my second switch there alphabetically, or my first one actually. So let me just copy that recording. Let's see, 1 second. Sorry, I know you won't see this part Rack recordings. I don't think I exported that. Okay, so yeah, we'll go back. Let's go back to Audition here. So here was this one right here. I'm gonna see if I can make it loop a little less abruptly. So what I'll need to do is probably like offset this and do some cross fading to avoid that click. It can be difficult to seamlessly loop, and I'm not an expert at this. So if anyone has tips, especially I'm looking at you, C. Grover, I know you know how to do this in probably 10 different ways, but I'll take it as it is right now and export it. And call this 1. Same settings, 16-bit, mono, 22050 hertz. Okay. Andy, I agree. I think that list of files that's printing there is coming from a ghost. I don't know where that's coming from. So let me copy. I recommend saving somewhere real and then moving stuff over to your SD card. Ambient machine, samples. Okay, so let's go back here. There we go. Oh. So Todd made a good point. I wonder, he wonders if I just unplugged another CircuitPython board just in case that was part of the weirdness here. Let's see. Hey, one of them showed up. It's so weird. I wonder if this requires like a power cycle to get that list correct. No, because it's now got 2 of these. That's a mysterious mystery. I don't get it. Oh, you know what might be interesting is to print the contents before the sort. Because where am I printing? Wave file sort. Print. Aha. So if I print the file name, it shows up. Something weird about that. Something weird happens there. What's in the box? Asked Dexter. It's chimes and strings and robots. So that's what's in the box, Dexter. It's a Metro M7 with an I2S audio out. I have a bunch of switches. I have a expander. They're spooky things, Snaky Maker Cat says. There are spooky things. One of the ideas interface-wise, based on the original, so this, by the way, I should give credit where it's due again. This is based on an existing product by Yuri Suzuki, and here's what it looks like. This was made in a limited run and sold at an art gallery, so you're not gonna probably find one of these too easily. So I'm making the IKEA box version of it with some slight changes, but that is the Ambient machine to answer that question. So that's what I've got. Yeah. So again, if anyone has any ideas on SD card stuff, let me know, but it seems like we should be able to bail and do some looping, some shorter looping wave files along with some synth.io stuff so that we can mix in a bunch of different sounds for either a spooky atmosphere or other. Could be cool to boot up 20 totally different samples or 16 totally different samples at startup just off of the SD card and then have those to work with. That might be a nice UI thing. Let's see, other notes from the Discord. C. Grover says, you magnify the waveform and edit at the 0 crossings and may have it as a selectable edit option. Thank you. Yeah, so this is a lot of clicks and things happen when a wave at the end of your sound file is on its way down, and then at the very beginning of your file, if it's on its way up above and not still on its way down below the 0 crossing line, that's a place where we get clicks and things. And also just kind of mixing and matching the sounds up a little more so it's not a sudden abrupt change will help. I could also I could design sounds that loop in my VCV rack or however I'm making them. So that's another option, is to create sounds that just loop well on their own, especially ones that fade in softly, long reverb tail, fade out, done. That will just be a very easy thing to loop. But I think that's it. So thanks everyone. I know we went a little long just because I wanted to show some of these editing techniques for generating the sound and putting it on there. Thank you everyone for your help in trying to see if we can come up with the proper SPI bus stuff. Let me know if you have other ideas on that. I think that's going to do it. So before I go, I will remind you, you can grab yourself 10% off in the store with the coupon code LOOPER today. So head to Adafruit.com, check out the cool stuff in the store, such as, not that, you can't get one of those, but get the parts for it. I'll be putting out a Learn guide, and I'll use some of these fine things, including 20 of these great little switches here. You'll have to go to your own IKEA or order online to get the cool Baltic birch box I'm using there. But either way, go find some good stuff in the Adafruit store. On the way out, type in Looper and you will get a 10% discount. Also remember, if you want to know what kind of discounts or goodies, I should say, you can get at different price breaks. For orders of $149 or more, you can get a KB2040, and for orders of $299 or more, you can get a Circuit Playground Express. Those are the current deals. I know sometimes we have others, sometimes we have some UPS ground shipping, but right now things are a little up in the air and wild with UPS, so that's not there. The freebies can change, so stay tuned. If you have a big order planned, you might want to look and see. We don't know what they are until they happen, so I can't give you any heads up on them, but go get some stuff. If you get a bunch of it, you'll get some cool freebies, and if you either way want to get 10% off, just type in Looper. By the end of the day today, I think it's midnight on the East Coast US time is how long that coupon code will last for. All right, I think that'll do it. Thank you everyone so much for stopping by. It's a lot of fun to have you here in the workshop and in the chats. Thank you. Randall Bone says beep beep. Thanks for stopping by in the YouTube chat. Thank you everyone over in Discord and everywhere else. If I'm not seeing your chat, I still appreciate you watching. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. I will see you next week. And don't forget to tune in tomorrow for a deep dive with Scott Tannute. We'll be back with a deep dive Friday. All right, thanks. Bye-bye.
Thank you.